Okay, so we're going to be looking at the notes for section 4.1. So we're talking about, this is our first section that we're going to be doing, and it's dealing with converting angles and arcs and things like that into radian measures. And most of the information that we're going to be using this semester is on radians. So basically the first page I'm going to get you to read over. It talks about the angles and what is meant by an initial side and a terminal side. So when we talk about angles, we're always thinking about an angle on a quadrant. So the initial side is the x-axis, and the terminal side is wherever the angle ends. So this would be the terminal side, and this would be the initial side. So the end point in our cases is always going to be the origin. It's going to be the vertex, or the vertex is always going to be at the origin. So we have to keep that in mind. So when we talk about an angle having a positive measure, so this angle up here is about 120 degrees. So that's a positive number because it moved in a counterclockwise manner. Okay? If the angle moves in a clockwise manner, so if I move from here down to here, then that would be considered a negative angle measure. So that would be like a negative 45. So clockwise is negative and counterclockwise is always positive. So one complete rotation around an angle is 360 degrees, or in radian measures 2 pi. And what we're going to be focusing on is how to find those radian measures and also how to get numbers in that range of 0 to 360. So this is just some basic definitions. So straight angle is 180 degrees, a right angle is 90 degrees. Acute angles are less than 90, and obtuse angles are more than 90. An angle is complementary if it has a measure that equals, two angles are complementary if they have measures that equal 90 degrees, and two angles are supplementary if they have measures that equal 180. So if I wanted to find the complement, I'm just going to take 90 minus the angle, and that's my complementary angle, and 180 minus the angle would be the supplementary angle. In this case, where I can't subtract 90 without getting a negative, we would say there is no complementary angle, and the supplementary angle would be 55. Okay, so one of the big terms that we're going to be talking about is what we call coterminal angles, and we're going to use this again when we talk about reference angles. Typically, coterminal angles are some number between 0 and 360. That's not always the case, but we're going to be using it most of the time when we're looking for numbers between 0 and 360. So if I give you an angle that's 550 degrees, that doesn't really make sense when we're talking about a circle. So what we need to do is get that number within 0 to 360 so that we can use it in some manner that we're going to be talking about as we go along. So in this case, I'm going to subtract 360 from it and I get 190. So the coterminal angle is 190, and the original angle is actually in quadrant 3. So when I think about this, 550 means I started here, I went around the circle one time, that's 360, and then I went around the circle one and a little bit more. So there's 190 degrees right there. Okay, so negative 225. This time I'm going to add 360 and I get 135 is the coterminal angle, and that angle is in quadrant 2. So here's what happens with that. So when I, again, start here, negative 225 means I went in the clockwise direction, and I stopped right about here. So there's my angle, negative 225, but we would also call that positive 135. Oops. Okay, our last one is 37, and this is where we were talking about we always usually want to get numbers between 0 and 360. So technically, I would say I don't need to get a coterminal angle, but if I ask you for one, you can either add 360 or you can subtract 360. So adding 360 gives me 397, and subtracting 360 would give me 323, negative 323. Alright, so what we really want to focus on today is how to get radian measures. And radian measure is another way of measuring angles. And radian measures, there's a formula, is theta equals S divided by R. So in this picture, theta is the angle, and remember we have our terminal side and we have our initial side. R is the radius of the circle that's formed. Theta is the angle in radians. S is the arc that is created by this angle. So S is what we call a subtended arc. So theta is the ratio of S divided by R. So theta is equal to S divided by R. So again, theta is the radian measure, that's what we're looking for, and R is the radius of the circle, which in most of our cases that we're going to be dealing with is going to be 1, and S is the arc that is formed. So there is no symbol for theta and for radians. So usually if you've got an angle and I say this is the angle measure and there's no degree measure next to it, then we assume it's radians. So this formula, there's two different formulas in your book. This is a different formula. This formula is going to be the one that we're going to use to convert from radians to degrees or degrees to radians. So you're always going to have the radian measure over pi, and then the degree measure over 180, and then you're going to cross multiply. So our first examples here, we're converting degrees to radians, so we set up our formula. We're going to take the 60 divided by 180 and reduce it, and it comes out to be 1/3. So then if I cross multiply, I'm going to get 1/3 times pi, which is also can be written as pi over 3. So 60 degrees is the same thing as pi over 3 in radians. Okay, here's our next one. We have negative 315 degrees, so we're going to put negative 315 over 180. We're going to reduce this fraction and get negative 7/4. So the radian measure is negative 7 pi over 4. 225 over 180. Reduce that fraction as 5/4. And then I'm cross multiplying, but I end up with radians as 5 pi over 4. Okay, the next examples we're going the opposite direction. So this time I'm going from radians to degrees. Sorry. So I've used the same formula. R is the radians, D is the degrees. So I'm taking radians over pi equals degree over 180. So then what happens is the pi's are going to cancel out, and I'm left with 3/4 equals degree over 180. And again, when I cross multiply, I get degrees as 135. Now in this case, 1 is my radian measure, it's not my degree measure, so I have 1 over pi, degree over 180. So when I cross multiply, I get 180 equals pi times d, and then I'm going to divide by pi, so I get 180 divided by pi is my degree measure for that angle. Last one, 5/2 pi over pi. Pi's cancel out, I'm left with negative 5/2 equals degree over 180. Cross multiply and I get negative 450. So then here I have two examples of word problems that involve using that formula. This is written a little bit differently. Theta equals S over R. So S in this case is the length of the subtended arc, that's what we're looking for. Theta is the measure of the angle, and R is the radius of the circle. So in this case, theta has to be in radians. So we need to convert this to radians. So we've got theta over pi equals 120 over 180. Reduce the fraction and I get 2/3 pi. So in this formula, theta is 2/3 pi, S is what we're looking for, and R is 10. So when I cross multiply, I'll get 20 pi over 3. So what that's saying is that I have a circle with a radius of 10, and I have some angle, the angle is 120 degrees, and I'm looking for the measure of this arc right here, okay, and the measure of that arc is 20 pi over 3. Alright, so here we have another example. What I want you to imagine here is like a bicycle, right? So you have your smaller wheel on the bicycle chain and the bigger wheel. The bigger wheel has a radius of 10, smaller wheel has a radius of 6. So what I'm asking you is that if I make one revolution of this big wheel, one revolution would be 2 pi. If I make one revolution, how many times does the little wheel turn every time this big wheel makes one revolution? So one revolution would be 2 pi, and I'm looking for the theta value over here. You have to understand that if I have a point here and I rotate that point a certain amount, it's going to rotate the same amount here, it's just going to rotate more times. So the values of s in these two problems are the same. So s is equal for both of them. So basically what I'm doing is I'm taking r times theta for the first one, and I'm setting it equal to r times theta for the second one. In the second problem, I know theta is 2 pi. I don't know theta in the first one. My radius in the first one is 6, and my radius in the second one is 10. So when I solve this, I end up with 10 pi over 3. So that means that this circle has rotated completely one time. That would be 6 pi over 3. And then it's rotated about 4 pi over 3 more, so it's made about 1 and 2/3, or 1 and 4/3 cycle through. Okay, so the last thing in your notes is what we call the unit circle. So what we have here is we've basically written all the degrees and the radian measures for every angle on the circle. So 0 and 360 is our starting value. That can also be called 2 pi. 30 degrees is pi over 6. 45 is pi over 4. 60 degrees is pi over 3. 90 is pi over 2. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 180 is pi. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7, oh, that's funny, 7 pi over 4. 330 is 11 pi over 6, and then we're back to 2 pi. So this is something you're going to have to memorize, and so suggestions on how to memorize it. So basically what we're doing is we're counting by pi over 6. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. And then you reduce some of those, like 10/6 reduces to 5 pi over 3. And then we're going to go through and we're going to count by pi over 4, or 1/4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And then to get our degree measures, we're going to count by 30, and then we're going to count by 45. So 30 plus 30 is 60, 60 plus 30 is 90, 90 plus 30 is 120, 120 plus 30 is 150, 150 plus 30 is 180. And then count by 45, 0 plus 45, 45 plus 45 is 90, 90 plus 45 is 135, 135 plus 45 is 180. So this is a circle you're going to have to memorize, and we will definitely have a quiz on this coming up. So, hope you have a great day.